now that the agenda stays the way it is, do I have a motion to approve the agenda?
Move to approve the agenda.
I'll second. All in favor?
Aye.
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 Okay, I guess we're gonna do the action item first, as we finally decided. To go with task order.
So we've got a new clicker here. So, all right. Well, good morning. We're here today to talk specifically about a task order that we're bringing forward to do a landfill leachate pretreatment study. But to get it started, we wanted to do a little bit of an update, particularly because this was mentioned at the last meeting on our progress on PFAS, and this is going to be focused specifically on wastewater. And so as we were working on the planning for Broad Run Phase 3, we had already taken an approach of making sure that whatever we were going to design was looking forward towards regulations and contaminants of emerging concern. And PFAS in specific is breaking down into 3 categories. So you have point source reduction, right? That's stopping the PFAS before it gets to the plant. And then once it is already in the wastewater, within the treatment plant, we would then look at removing PFAS from the liquid stream and then removing PFAS from the solid stream. And those are 2 different technologies and processes, and both must be addressed, right? So the liquid effluent from Broad Run, right, discharges to surface waters. So is therefore, going to be adding PFAS back to the environment, even though we're not producing it, right? We're just the passive receivers. And then the biosolids is what we talked about previously, where the solids that we generate also contain PFAS, and those are currently going towards land application. And really each of these areas, regulations are still pending, so there are no requirements for wastewater treatment plant to remove that right now. So what the entire industry, academia, regulators are all focused on, and staff here at Loudon Water, is understanding in each of these categories what can be achieved. So how much of this material are we able to remove with technologies that we have right now? And what's it going to cost? Because this is a really important factor when looking at removing something at this low of concentration, this difficult of a chemical and scale. It's going to be very costly in the end. So we need to know both of those, right? How much can we remove, and what is the price for that? So we've been working in each of the categories specifically. And the reason why we wanted to do this presentation first is this does feed into our overall work that we're going to give on the informational item for Broad Run Phase 3. So in the point source reduction category, what we have control of in the wastewater is the landfill leachate. This is our one major known point source of PFAS entering the sewer system. So a landfill is just like Broad Run, right? Where they're taking all of the household waste, all that food packaging, all the microwave popcorn bags, all the clothing, and it's all containing PFAS. When it rains, right, the PFAS gets into the water, and that water is then pumped to Broad Run for treatment. So they can't control the PFAS either. So our option on the leachate is really to look at how do we remove it from this really concentrated small waste stream before we basically dilute it by putting it all of Broad Run's wastewater. And we'll talk more about that in the presentation today. So that's the scope of today's presentation, is our focus on point source reduction. All guidance says this is what you should do first, right? See how far you can reduce this before it gets to the plant, and then look at what's left over to treat. So on our liquid stream treatment, we're really lucky that Broad Run already has granular activated carbon. It's one of the most mature technologies that people are looking at for PFAS removal. And so our plans in the Phase 3 program work are to really evaluate how do we optimize the process we have. To date, we've been utilizing it for carbon removal. Well, now we might need to operate it or treat the material differently to get enhanced PFAS removal from that system. This is really important piloting work because very few wastewater treatment plants have this full-scale process right now. So this is also another way where Loudon Water can help the industry, right? The data we generate from our process will inform many other plants that are having to look at going down this road. Biosolids treatment is much more difficult right now, and there are few mature technologies available to fully destroy the PFAS in the biosolids. But we do know that to get to the treatment process that we know of, which is called pyrolysis, we need to utilize thermal drying to process our solids. And so this is really, we've selected our path for solids in phase 3 to position us for dealing with PFAS in the future. So there's not a mature technology that we can say, come on, let's go ahead and build this, but we want to make sure anything we're building, right, lines up with how we're going to remove that PFAS once the technologies are available. So thermal and drying is an important step for us. So all of these together are very, very large undertaking, right? In really figuring out how are we proactive and how do we address this in the multiple areas that we have to tackle it. But
Do we have thermal drying now?
no, we do not. So we are doing anaerobic digestion, just followed by dewatering. And I would say very few facilities nationwide are utilizing thermal drying because the technology is expensive and it doesn't scale down well. So to date, Broad Run was too small of a wastewater treatment plant for that technology to make sense. The dryers, we've gone to see one now, you know, these are massive pieces of equipment that come in set sizes. So when you're a really small plant, it's too big, it's very expensive. So really, we're getting to the size of the plant now that it makes sense. So it was an optimal time for us to make this switch. One, because it becomes more cost effective now, and two, because we knew the regulation was coming. So we're going to focus on the specific study that we're bringing forward today. And the whole point of this study is for us to look specifically at that leachate stream and do what I was talking about, determine what PFAS can we remove and to what level, and how much is it going to cost? Because we need to weigh that versus what treatment costs at Broad Run might cost, right? If we didn't pre-treat that landfill, right? Maybe it turns out it's most cost effective to just treat it Broad Run. I doubt it, but it's worth the due diligence to do it. And also we need to know which specific types we can remove and what level they get to, because otherwise we'll design things at Broad Run for the wrong constituents, right? This will impact what we have to treat there. So it's critical for us to know this now so that we design the proper systems for Broad Run.
Just curious, with the process of going from point source to water waste treatment and the biosolids, is that a sequential process in terms of removing PFAS? Or do you see the wastewater treatment and biosolids occurring concurrently?
They occur concurrently because as you treat that liquid, you're generating the solids. So you need to do both of those together.
So really you're looking at a cost benefit analysis on the point source and seeing what the PFAS levels are then, and then evaluating after you've done the other two.
Yep. And that point source reduction will affect both of those other systems.
Okay.
So just a little bit of background on our landfill. So the Loudoun County landfill, it's a municipal solid waste landfill. So they don't take hazardous waste, they take construction material, household waste, and they are located right on the, oh, look at that, there it goes, you know, the border of our service area. We've talked about this a little bit before, but our central service area, the blue portion, discharges to the Potomac Interceptor that goes to DC Water. So all of the wastewater in this area does not enter our treatment plant, right? We pay DC Water to treat that. Everything in the light brown, which includes the landfill here, that comes to Broad Run. We have no ability to switch that flow and say, you know, maybe we should send that to DC Water. That is all our flow that comes into Broad Run. Broad Run is located right here. I was also astounded at the difference in size between the landfill and the treatment plant. This purple area is an area where we have options. This flow can be sent either to Broad Run or to the PI, and we are controlling that flow to manage our PI allocation. So if you recall, we can send 13.8 MGD to the PI through our agreement with DC Water. And so we manage that as closely as we can. And so right now, we bring about 2 MGD from this purple area into Broad Run, and the other approximately 4 to 6 discharges to DC Water. But the important part for us is the landfill must come to Broad Run. There's no future where that might switch and not come to the facility. So understanding what landfill leachate really is, as we've been going through this study, I have learned a ton about landfills. And so the Loudoun County landfill, this is just a generic figure, and my citation got cut off at the bottom, but in general, this is how the majority of landfills are set up, and Loudoun County's landfill does have these. There's a compact clay liner along the bottom because landfills are open on top while they're being filled with waste, right? So when it rains, the rainfall is falling over all of that material, and you're getting a very concentrated waste. It's high in organics, it's high in ammonia from all the food waste that's in there and things it's coming into contact with. There is a perforated pipe underneath the big waste pile that collects all that leachate that settles on top of the liner. You don't want it going into your groundwater, right? Old landfills were unlined, and they were seeing large portions of groundwater contamination. So that's why you'll see groundwater monitoring probes here. So even when they're lined, landfills still have to check to make sure that they're not having, any leaks or anything in their liners. But the leachate, it can really vary a lot. So even on dry days, we're getting leachate, right? There's always water in there, but when it rains, that can increase by a factor of 100, right? What we get out of that, because it's really open stormwater, right? Coming right through there and being pumped to the wastewater treatment system. And so it's this contact with the material that is taking the rainwater, it's accumulating all of that PFAS and many other contaminants, and we're getting a high strength waste out the bottom. And so we're going to talk a lot in some detail here about PFAS treatment technologies. Is a little bit more of informational, but what's important to see is when we say PFAS, it's a family of chemicals. And what we're giving here is our measured concentrations of some of the PFAS constituents in the leachate from our landfill. Now, this is the whole point of the study, is to decide which of these constituents can be removed, because each PFAS is different. It will take different technology removals to remove them. They also have different levels of toxicity. So for example, PFOA, when the health advisory came out for that, right, for the drinking water, they said PFOA should be limited to 0.0004 nanograms per liter, right? But PFBS, they said the health advisory for that is only 2,000 nanograms per liter. There's a huge difference in those numbers, right, for the health advisory, because PFBS is a short chain PFAS. We're going to talk a lot about the difference in these. PFOA is a long chain PFAS, so the chemical structures are very different. The short chain PFAS in general seem to be less toxic to humans and other animals than the long chains. The short chains are the hardest to remove. So many of the technologies we're rolling out, we can tackle these long chains, but we're really struggling with the short chains.
They come from the same type of source?
They're all various sources.
All over the place.
Yeah, all over the place. And what we're also finding is there seems to be a pretty common signature to the chemicals you're saying specific to landfill leachate. So we've been looking at the constituents that we see in Broad Run and comparing it to some other wastewater treatment plants. And then we see some unique forms of PFAS, particularly in these acids at the bottom, that have really a landfill signature on them. So it's things like that that we're hoping if we can target these with removal at the plant, then we could assume most of it from Broad Run would disappear. And now it's a whole family, right, that we wouldn't need to worry about because they seem to be landfill specific forms. But estimating the capital and operating costs of this pretreatment system are really critical to the evaluation. So our 3 goals are knowing which of these constituents we can remove, what level they can be removed to. So we're never going to get 100%, right? So we need to know, are we looking at 70% removal or can we get to 99? That's going to make a big difference on the downstream system.
Excuse me, Kendra. Just want to get clarification when using the term long chain. Are you referring to like the chemical decomposition or the breakdown of the PFAS in natural breakdown, or what is
breakdown and more its structure? What they actually do is they count the fluorines, right?
Okay.
So one of the key characteristics of PFAS is how many fluorines are attached to the carbon. And so they've really got a general rule of thumb, right? Anywhere from 5 fluorines or less, you're in the short chains, 6 to 7 or more, you're in the long chains, and there's always a fuzzy area in the middle. But when you break them up like that, they do tend to fall into categories that behave differently.
Okay, so it really has to do with the chemical composition, not the decomposition of the PFAS.
Yeah.
Okay, thank you.
Okay, so what we wanted to quantify here is all the ways that this study will impact what we're going to do at Broad Run, right? This is really why it's critical for Loudon Water to move forward with this study now versus waiting to see what regulations might say. And this is really because we're building now. Because we're in expansion mode for the plant, we need this answer to know that we're building the right thing and our plan is going to work once pretreatment of the landfill leachate is in place. So it can affect the number of granular activated carbon reactors we have. It will definitely affect the frequency of carbon replacement. So these are, large reactors, right, lined up. They span longer than this room, and the carbon inside must be replaced right now every 5 years, which is a huge undertaking for staff. The carbon itself has a cost. And so knowing if that 5 years moves to every year is critically important. 1, for the budget, 2, for staffing levels. And so if pretreatment at the leachate can reduce that frequency, there's a large long-term cost savings for the operation of Broad Run. We also need to know then how much of the PFAS still passes through GAC and ends up in the effluent, so that we have an idea of, once we have this treatment technologies in place, what does our effluent look like then? And also we need to know, because our biosolids process, wastewater passes through the plant in about a day. Biosolids stay in our plant for 30 days before they're discharged. So they're accumulating PFAS from the wastewater day after day. So you'll see increasing concentrations there because it's when PFAS is removed from the water, it's moving into the solid form. So we need to know, if we don't have it in the first place, how much does that affect that accumulation process? What we're also going to talk about is PFAS precursors. We can measure, 30 PFAS right now. And when you look at what happens across a wastewater treatment plant, you will see forms of PFAS in the effluent that you didn't see in the influent, because there's so many various forms that are in the unmeasurable that we can change into a form that we're measuring just by oxidizing it over time. So knowing those precursors also helps us know that pretreatment will get rid of many of those precursors. So we might see less transformation or different types of transformation. So it's all so critical. We essentially can't, at this point, reliably design a system without knowing the impact that this is going to have on the facility.
Are you saying that one possibility is to intercept it partway through the treatment train where it's easier to process?
So we're trying to intercept it before it even enters the collection system. So this pretreatment will remove it before it's entered the large wastewater stream. So if we think about Broad Run treats 8 million gallons of wastewater a day. The landfill leachate discharges 7,000 gallons of water a day, right? So it's a very, very small stream, but contains 20% of the PFAS load that we see to the plant. So it's much easier to treat 7,000 gallons than it is 8 million gallons. And that's where the cost effectiveness comes from, is we've got this small concentrated stream and we want to target that to hopefully require less treatment on the big 8 million gallons. And that's the theory between all point source reduction.
I thought the leachate can't be a large amount, but
Yeah.
that's a good point.
Yeah. So the specific scope of our study, we've got it broken into 2 sections. The first is what we call a paper study. And this is engineers looking at the leachate pump station and understanding what flows are now, what those flows would look like in the future, because we have to know as the landfill opens or closes cells, is that 7,000 gallons going to go up, down? How might it change? So that if you're designing a system, you've covered its full operating range. So we're going to go through and look at all available treatment technologies for landfill leachate in specific. And I just want to mention that the industry is really working on this. This is all in the research phase. There's very little of this commercially available right now. It's all at the testing scale, and everybody is just testing as fast as they can. So this study is another great data point for the industry to have more leachate out there and say, this is how these emerging treatment technologies performed on this specific waste stream. So we will screen them just by, an evaluation matrix to start off with and say, based on specific characteristics, we know these won't work, and we'll end up with a pile that we think work. At the paper study level, we're going to get layouts developed so that we can get capital costs. We need to know the footprint of their treatment system and how much that's going to cost to build. We also need to know how much to operate that system is going to cost. And we'll talk more about that later. The other thing we're going to get in the paper study is a roadmap to implementation. Because we're still at a research level, you don't go from the results of this study to building something, right? There's more work in between to really flesh out what needs to be built and ensure that it's going to work. We're also, completing this study ahead of knowing what final regulations are going to look like. Regulations are pending that will say all landfill leachate needs to be pretreated. So those regulations will come out and say that leachate has to have a certain amount of PFAS removed prior to discharging to a wastewater treatment system. So we'll see that number hopefully at the end of 2022, probably early 2023. So we know that one's coming. But we also are waiting to see what regulatory limits might possibly come out for Broad Run. So the roadmap will help us understand what implementation looks like and how we watch these regulations as we go along. But the paper study isn't sufficient. Because we're in the research realm, we can't look at a technology and say, we think it's going to remove 90% of the PFAS. So we want to do a bench scale treatability study. So this involves sending 600 gallons of leachate to the consultant's lab in Bellevue, Washington, where they have bench scale versions of 3 of the most promising technologies, and they're going to treat the county's leachate. So we know specifically on our waste stream then how much of the PFAS and what type we can remove and how feasible these are going to be. Because as I mentioned, leachate has a lot of other constituents in it. All that carbon, all that ammonia, it creates interferences with many of these treatment systems. So we'll know for this specific leachate, does it need to be pre-treated? It might have a treatment step before it enters the PFAS removal technology, but this is the critical step for us. A paper study really just gets us some numbers that don't have a lot of meaning, but physically testing the leachate itself gives us the confidence that we need to say this is a sound number, it's a good planning direction, and really both the county and Loudoun Water can use this information going forward with more confidence. So That was a lot. And this is really the informational section where I wanted to talk some about the technologies and the difference between PFAS removal and PFAS destruction. At the last board meeting, there was some discussion about some new articles coming out, right, about advances being made at the research level. And we want to tie that in to what we're doing. But just want to pause there on what we've talked about this far in the specific leachate study before we get more on the technologies.
When you talk about the three technologies, are they all focused on PFAS removal or destruction?
Yes.
So PFAS removal.
PFAS removal is
Okay.
the realm we're in right now.
Okay.
Destruction is several steps even further into the research realm. But our costs will include costs for that ultimate destruction, assuming that the landfill will send a concentrated from their removal system somewhere for destruction.
And you also mentioned that there are certain policy that has not been determined in terms of the percentages that we'll have to adhere to.
Yeah, absolutely. And we've asked ourselves that question a lot, but the way it looks right now, what we're evaluating with this bench scale test is the exact same thing that the regulators are doing. So we feel very confident that we've got a wide enough range of technologies we're evaluating that will hit one of the answers we think they're going to hit. But the important part is this is just a study. So the building is where you really take the risk, right? Without knowing the regulation to say that it's the right technology. What we would then have from this study is a nice menu when that regulation comes back and say, yep, you know, option number one met the menu of what the regulation needs us to achieve, or maybe we have to combine two options to meet that. But we'll have the information ready as soon as we see that regulation.
Thank you.
Getting off the subject. But what is the life of the landfill?
Absolutely. It's a great question. So we've asked them that to know, you know, are they going to close in 10 years and not be a problem? They currently project being open through 2070. All right. So exactly what you were asking about there, Mr. Moody. So what we're going to be looking at is definitely not going to be a simple process because landfill leachate is very what we call dirty, meaning it has a lot of different constituents in it. It is likely going to need a pre-treatment step. And as I was preparing the presentation, I was like, ooh, we're using the word pre-treatment a lot, but it's a small step to remove a lot of the things that aren't PFAS so that we have less interference when we hit our PFAS removal technology. PFAS removal is, and I've told you the leachate is a concentrated stream. It's concentrated compared to our wastewater, but in terms of destruction, it still has a lot of water in it. So you wouldn't be able to apply a destruction technology directly to this flow. It has to get more concentrated first. We need to be seeing PFAS measurements in the milligrams per liter instead of the nanograms per liter, right? To be able to use these destruction technologies. So we are studying how they can remove it so that their treated water can then enter the collection system without contributing PFAS to Broad Run. We will include operating costs to so that the landfill is covered on how this PFAS destruction might be handled. So there are currently some destruction facilities that this material can be sent to. Honestly, most of them right now are incineration, and the science is showing incineration really isn't great for PFAS, but there's nowhere else for it to be sent yet. But the, again, science, academics, the industry, everybody's working on PFAS destruction. There are promising technologies. They all just need to scale up and be brought to market. So the thought is in the next 4 to 5 years, there will be large scale PFAS destruction tech centers, because it also becomes very uncost effective. If we all have a really small stream and we all build PFAS destruction, it makes sense to start having more centralized facilities, which is what we do for hazardous waste right now, right? So I told you this landfill can't take hazardous waste. we have larger centralized facilities built at a much higher level that handle that hazardous waste. So there will likely end up being PFAS processing facilities that look like that.
Just curious, you mentioned incineration is not good for PFAS removal or destruction.
Yeah.
Does that release it into the air? What is that what it
It
does?
seems to be going into the air
Yeah.
and not fully destroyed. So there's several studies waiting on data, but it seems to be the direction that it's leaning. And just goes to show
Problem
it's a
from the
forever
hazardous,
chemical.
hazardous waste landfill? What happens there?
You know, I actually know very little about how much PFAS might be in a hazardous waste landfill.
Because it seems like you'd have the same issue.
Possibly. I would say we know the main sources of PFAS are from normal household waste, right? So the food packaging, the clothing, and none of that's going to a hazardous waste landfill. So at this point, I just don't know what PFAS streams they would take. I just know very little about those types of landfills. The first process that is included in our bench scale study for the leachate is called co-precipitation. So what we found is there are specialized coagulants that you can actually add that encourage PFAS to absorb onto molecules when you have other conventional coagulants like powder activated carbon and ferric chloride that make solids settle. So essentially it's another chemical that you can put in to encourage that PFAS to fall out in the solid stream. This is actually also a technology that we're going to consider piloting for broad run as well. If we can add that coagulant ahead of our GAC and encourage it to fall out of the liquid stream, it may help our final effluent. So we absolutely need for the leachate to evaluate what types of coagulation are going to help prepare and reduce contaminants. Most likely, this will end up to be our pre-treatment step before the PFAS removal technologies that we're going to talk about. However, there's a chance that this could be good enough that it's the only step we have to take, right? And we would all be so happy if the only thing we had to do to that leachate was really let it, add some chemical, let it coagulate, which means everything's forming particulates, and settle that and have a solid stream to process. So, fingers crossed, that's where it comes out. But there are other more sophisticated technologies that we're going to test as well. So I talked already about granular activated carbon at broad run. We'll evaluate that for the leachate step as well. A really similar process to GAC is ion exchange. So these are both medias that are specialized to absorb PFAS. The problem with these medias is they absorb a lot of other things besides PFAS as well. And when talking about the different types, they also mainly remove long chain PFAS. So again, this is another technology that's good at the long chain, not as good at the short chain. But it's important for us to know, so we will run at the bench scale. These are small scale rapid testing units with different types of media inside. So we'll be running the leachate through to understand how much water can flow through that media until we start seeing PFAS breakthrough. That lets us know what level we can remove to and how often we'll have to change out the media. And the media costs are really the big concern with this technology. It seems to be looking like that a lot of media is going to be required. So that operating cost is critical for evaluating it. The next technology is a little different than what we've talked about thus far. It's called foam fractionation. So what this involves would be taking your leachate and literally bubbling air through it, pretty similar to what we do in a wastewater treatment plant. However, they add a cationic foaming agent that gives the foam a slight electrostatic charge. And PFAS, because it's so big, actually does have a slight charge to its ends. And the foaming agent that they found has made this actually very effective in removing PFAS. So there's a lot of potential for this. It's being evaluated several places specifically for leachate. And so you get a foam now with concentrated PFAS in it. And they've designed, the company working on this has a proprietary vacuum that sucks the foam off the top and you turn it back into a liquid. And now you have that super concentrated liquid PFAS stream for disposal. Foam fractionation is really being shown right now on this small scale. So we haven't seen it to say, like, is this a potential for broad run? Nobody's considered it at that scale, but it seems perfect at the leachate scale we're talking about. So we've got actually a lot of hope of doing the coagulant pretreatment that we talked about, and then through foam fractionation, that this could be a viable option for
What
the
happens to
leachate.
the liquid that,
You send it to a PFAS disposal facility at that point. So it has to go somewhere for destruction after it's been removed. So the last option is not going to be tested as part of our bench scale because this is like the hammer, right? So reverse osmosis is the technology that it removes everything. And it's extremely expensive. So the science behind reverse osmosis is you have your leachate on this side, so that's where all your contaminants set, and you apply a lot of pressure across a semi-permeable membrane and get fresh water on the side, and the contaminants stay on this side. This is actually an established technology for treating leachate. So there are some landfills located in places where there's not a wastewater treatment plant to discharge to. Most of those landfills will have reverse osmosis on their leachate, and the water really is at a quality at that point that it doesn't need wastewater treatment anymore. We've removed everything, but at an extremely high cost. The operating costs of this due to the pressure and the pumping are high. The membranes are prone to fouling, so you can run into issues long-term with membrane replacement. But this isn't necessary at the bench scale level and is really a last resort, right? Due to the cost. So if we get through this study and all of our other technologies are not viable or can't achieve low enough limits, we know, okay, our roadmap shows reverse osmosis is what we need to consider. And you really consider this at the pilot scale. They have trailer mounted units where you would bring it to the landfill and start evaluating that. But it is definitely cost effective to see if these other work before we get to reverse osmosis.
So sitting here, I have a few questions. First is, so what we're talking about today is, if I'm understanding this, is about the removal, right, of PFAS, right? That's great. How do we prevent that? Because we don't want to keep eradicating something knowing that it's still coming through and we're not preventing it. So is there like public awareness out there? And I know last time you talked about, talking to companies, for example, Chick-fil-A, their wrappers have PFAS in it. So, and you and I both know they're not going to do much about it, right? Right, they're not. So the removal is one part, but you and I both know the prevention is the other part, right? So
it absolutely is. And I would say there is a lot going on right now within, public utility sphere. I've seen, numerous attorneys talking about this. And I know Amanda is up to speed on it, but everyone is saying this, right? And state by state, people, we've got legislation going through with people trying to ban PFAS in certain materials like packaging and food waste. The legislative process is slow, but we see it picking up. Everybody's really saying this needs to be handled on a national level, right? That all these companies span so many states. It's we can do what we can at a state level, but the federal government needs to take action on this, which is well beyond Loudon Water's control. And the federal government is just determined that they're going to go through their process. So they have issued a PFAS roadmap where they're studying all of this, determining health effects, and starting to make restrictions and limits. But we're on a scale of like 5 to 10 years for their roadmap to be accomplished. So states are trying. I think they've said, over a dozen states have active legislation saying in our state you can't use PFAS in materials in certain forms. But the federal government has really made their position clear that they're going to take the time it takes to study this before they take action at this point.
I mean, had I not been on this board, I would not know about this. Like, really, like, honestly, yeah, because, I mean, I think there is a lack of public awareness out there. You know, people buy these, people buy what they buy, right? They bring it home and they utilize it, and then it just goes in
And you think
disposal
it's
because,
safe, right?
yeah, because you have waste removal, you know, you pay for that and somebody's going to take care of that. I'm going to put my trash can out there. I'm going to put all this waste in there and it's taken care of. Next, what's next, right? So you and I sitting here, right? This is great. It's going to cost land and water, obviously. But yeah, and I'm, you know, sitting on the board, I wanted, you know, I have a fiduciary responsibility, and that is to also figure out how we're going to prevent that as well. So, you know, yeah, that being said, so I was just sitting here and wondering
Yeah.
about that. Yeah.
It's frustrating.
And the other part is the regulatory part as well, right? I mean, I understand intensely that you're saying that, yeah, that we have this, we're going to create our menu, we're going to do what we were going to do, and then we're going to parallel that and match it to the menu, which the other menu is the regulatory menu, right? We're using menu as an analogy here, and see, you know, what we can cross off our checklist, you know, so we kind of want to be ahead a couple of steps, you know, of the regulatory, because you and I both know the regulatories will keep changing because this is such a hot new topic out there that new regulatories will come in. I'm just concerned. I don't want us to be on a hamster wheel, right? Like trying to like keep up with the pace of this, right? Because I feel like that's where we're gonna go. But we know that even when we're on the hamster wheel, we're doing the right thing. We're doing the right thing. But it's just it's all sitting here on my side of the table. You know, we need to consider all that. So yeah, that's just the questions that's running through my mind right now.
And what you're suggesting absolutely needs to happen. And we, you know, as I'm kind of restating what you said, we want to stay as proactive as we can in the areas that we have control. And I think we're doing a great job at that thus far. And we want to continue that with this study.
Oh, hands down. I mean, I was waiting to thank you guys in the end, because to me, a great presentation and communication is you are successfully able to put that mental image in my mind of what, when, how, and how it's going to impact us short term and long term. So it's thus far, it's a great presentation, because I always see if somebody is able to convey to me and help me create a mental image in my mind as to what you're trying to tell me and where you're taking me, that's wonderful. It's just, I had these questions. I mean, there's two parts, right? There's eradication, mitigation, and then there's the prevention of that.
Yeah.
So the prevention is the part that, you know, yeah, but great, thank you.
Has there been any public outcry or concern about this?
We have not seen any
That's why we have public policy, Marty.
yet. But I would say there has been outcry from every wastewater utility or water utility in the nation. That is where the action, the vocal, because the moves they're making are impacting essentially water utilities and landfills across the nation. And, you know, the actions they're taking, they want to do it for, you know, to make the industrial polluters pay the price. But landfill and water costs are going to pay the price as well, right? And they can't seem to separate these in the actions that they're taking. So, you know, we've been following it closely. I feel like we're also elevating on that scale pretty quickly to be vocal at that level too. So the, you know, NACWA, the National Association of Wastewater Agencies, has been all over this. They put out at least a weekly email on, you know, movements, updates. There's been so many statements. We've seen EPA coming to talk to us all more frequently, really trying to explain what they're doing and why it's not, you know, what we need, exactly what you're pointing out, right? Instead of, you know, forcing us, we need to be stopping the production. So I think, as seems to be the case, you know, water is the vocal voice really saying that this isn't going to work. It's breaking the system.
Right, stopping the production. I'm more worried about like consumers, right? Working with consumers, because consumers are powerful. We all are consumers and we are powerful. In the end, we have the last word on this. If we stop using it, they're going to stop making it because they want to profit, right? They want to do what they're doing because it's to their benefit, right? But consumers, if we put the decision in the end and we're not going to buy it, then, you know, this is a supply demand thing, right?
Yes.
They'll create the supplies, But if there's no demand for it and the demand goes down, then we've nailed it, to some extent.
Absolutely.
Yeah.
But I think a bit of the sobering truth to that is that we are still going to have to treat and be prepared for this. And it's just about, to Kendra's point, as we talk with the regulators, it's right sizing that to what's realistic and what's within the realm of what utilities can absorb from a cost perspective. And so, there's just a lot of action going on from all angles right now. And we're just going to continue to try to stay proactive.
Right. And we're doing the right thing here, right? We're taking action. We're not sitting here folding our hands and going, oh, we'll see which way we flow. No, we're going to decide which way we are going to flow based on our actions. So totally agree with you. Yeah.
The reason I ask about the public is out of the blue, my son calls up and asks if do I know anything about PFAS? Where he got that from, I don't know. Just out of the blue, which surprised me, so.
Excellent.
I just have a question in terms of scope of the study. I was initially under the impression that 3 technologies, but it sounds like it's going to be 2 because of reverse osmosis is not going to be included. Is that correct?
Right. We're
Okay.
considering the co-precipitation, essentially one of the technology evaluations.
Was that presented? I know you mentioned the ion exchange and the foam
Yes. So-
fractionization.
So this first step of co-precipitation rate, is really a treatment step in itself when you coagulate something. So, it sounds just like adding chemical. These become tanks with mixers and you allow the chemical to settle and then you have a settling step. So while co-precipitation sounds simple, it is a technology treatment process in its own when implemented.
Okay, so that would be potentially the third option, but it's not the same level as the others because it covers more than just PFAS, from what I understand. Right?
Yes. And will likely just be incorporated with the other technologies. So what will
Okay.
probably come out of the study is you do this first and then one of the other ones
Okay.
after it.
I see. So it's real, yeah, got it.
I noticed you mentioned ferric chloride and powdered activated carbon. Is alum still used as a coagulant?
It is. We use it in broad run. These were the ones recommended by the consultants on this level, and I am not knowledgeable enough at leachate to know why these would be preferred over that. But
I know ferric chloride is a bear to handle.
absolutely. But again, at the leachate level, it's very small quantities. We would be talking about, a drum with a drum pump type situation. All right, so PFAS destruction. I'll go through this quickly because we've done a lot of talking today, but everybody wants to crack this nut. Everybody wants to figure out how you destroy PFAS. And the thermal processes, like incineration, is what everybody looked to first. So incineration does seem to be releasing PFAS into the air. So pyrolysis gasification seem much more promising. They are similar to incineration, but you use much, much less oxygen. So you can contain what goes off in the gas form. We hope to be going to visit a pyrolysis facility in Schenectady, New York in the next couple of months, but it's one of the first to be up and running. EPA is doing sampling on that system. We've got the Water Research Foundation doing research. I mean, everyone's looking at this one facility, trying to get the data to saying, have we destroyed it? Are we capturing? Let's make sure this is really right before everybody has to go and build. So that top box is the closest one to being market ready. Everything below, and as we go down, we're getting into bench scale or even like lower research scales options. So all chemicals oxidize. It's a form to break apart that. So they're looking at electrochemical oxidation, where you apply a really large amount of current with your oxidant to kind of help that process. Supercritical water oxidation is another one that we've got one company that has shown up really trying to bring this one to market. And this is where you get water under high temperature and high pressure in this special area where it's not a gas or a liquid. But I'm sure you can imagine high temperature, high pressure looks like it's going to be extremely expensive. Plasma is super fancy, right? But if we hit it with a plasma ray, we can break it apart. Hydrothermal is also very similar. You're using water under high pressure and high temperature to break it apart. But the low temperature mineralization, this was the Northwestern study that we all saw where the news articles came out and declared, we've figured out how to destroy PFAS and it's very cost effective. We just used some really common solvents and broke it apart. So this was at a scale where it is manufactured PFAS, right? So it's not dilute, it's not in a waste stream, and they applied some solvents. It seems to work on some types of PFAS, but the sulfonic acid family, it doesn't work on. So of the 24 PFAS we normally measure, sulfonic acids are about 10 of them. So it might be a potential to destroy maybe half of the PFAS family we're looking at. But that's why we just wanted to illustrate that all the research, they have to iterate through these processes and try again. But PFAS is hard because it's so many chemicals and they've got so many different characteristics that even when you find something that works, the next moment, it only works on a couple of them. So really, the PFAS destruction just needs a lot more time. But if you notice, pyrolysis is what we talked about putting on our solid stream system. It's the only known technology that we have to get rid of the PFAS that would be in our biosolids. And as part of phase 3, we're going to get a small study so that we get, similar to what we're talking about here, footprint and capital costs to understand, is this something that financially, is doable going to that level at this facility?
So the reason why we're doing all this is obviously more so for health, right? I mean, because it's cancer causing, right?
They don't have the results back yet on the cancer analysis. So the health advisory levels that were recently issued were issued based on immune response suppression. So a slowed response to vaccines.
COVID vaccines.
Actually, no. I recently heard, and I don't have this from a written source, that it was the tetanus vaccine.
Oh.
And I think this is where these health studies just take a really long time. So it sounds like that was data they had, they needed to move. So they moved on, the tetanus vaccine while they're waiting. So the PFOA and PFAS were called interim health advisories because they're waiting on more information to come back before they finalize a health advisory on
Well,
those.
yeah, now I think about it, tetanus makes sense because every 10 years we should get a tetanus shot. And, if you have a cut or something, it's more metal related, right? I mean, yeah. So there's a correlation, I think, between tetanus, maybe in to that point, and PFAS.
I have no idea.
Because I'm trying to understand.
It's also been around a long time, tetanus vaccine.
Yeah. But I'm trying to understand if we were to go and present this out in the public, people will be like, okay, why are we paying so much attention to this? Like, how is it going to affect my health? You know what I mean? I can just throw that wrapper away from Chick-fil-A, right? But how is it affecting me, like health wise, or other parts of my ecosystem? So I thought it was, what I read from Brent was like, he sent to me something related to cancer.
Right. And I am sure there are articles out there. That is not the data that has been released by EPA.
So what's the effect of this? Like we understand the causes, but what's the effect on the long-term implication on a person?
So when they set these health advisories, so I don't have like the whole study or evaluation that they did on that. They picked the most limiting one, right? The most limiting was the immune suppression of vaccines. And so that's how they picked the health advisory based on that level.
Because I mean, I don't know if everybody takes tetanus or not, right? My husband has never taken tetanus, right? I mean, he hasn't, and maybe he has his reasons, I don't know. But if it's only for tetanus, I mean, we want to make a really strong, solid, case for this, right? If we just want to eradicate that. So.
Yes, and that is in the public health realm of what EPA is doing.
I think our main takeaway is that the results are preliminary and it's early and things are ever changing. And, we're trying to right size things based on that and set our pace of what we're doing based on, we know something's coming from the regulatory perspective, but we're not really going too far out on a limb ahead of that. And really, I don't believe this study is going too far because it does something that we know we're going to need to do with our phase 3 expansion anyway. But
Yeah.
back to your point, it's all very preliminary, and
Yeah.
Kendra kind of made the point, these things need to, be based on volumes of data over time. So
Right, right. If you don't scare it and don't stress it, then it just sits there, right? And we just
Mhm.
keep going on and on and on, and you'll keep coming back and doing a presentation and asking more money while I'm on the board. I'm paying for it, you're paying for it indirectly, but as a whole, Loudoun County is paying for that, right? I mean, I'm trying, you know where I'm going with this, so, yeah.
Most of the wrappers go into recycle. And how does whatever they do with that affect PFAS? In other words, they make it into new bottles or whatever it is, doesn't that,
Yeah.
what happens with PFAS in that situation?
So again, I am not an expert on recycling, but my understanding is they can only recycle material, paper material that hasn't been processed. So most of the food wrappers that have PFAS on them are, shiny, slick. They screen all of that stuff out and it just goes to the wastewater treatment plant. So even though you put it in your recycle bin, they're
Still
only
goes.
pulling out, cardboard or paper that hasn't had any kind of processing.
Yeah, I mean, I was going to talk to you on the side about that, like not take up your time and, sway you away from the presentation, right?
Yeah.
But it's like, okay, it's going to the recycle bin, but now I'm sitting on the board, I have to think, how does it go from the recycle bin into the landfill and how it's, taken
Yeah.
care of? Because money is getting involved here, decisions are going to be made, so.
Absolutely. So, schedule and budget on the projects. This was an excellent transition. Schedule-wise, this is going to be a 9-month study. So we're, hoping to get authorization here from the CIP committee, take it to the October board. And we'd start with 2 main steps. One is shipping all that leachate to Washington. And then also, our evaluation of the pump station. The bench scale testing is estimated to take 6 to 7 months. The majority of the time here is really going to be waiting on the PFAS analysis. So we've had a lot of talk about how this is becoming a higher and higher priority. It is taking us longer and longer to get data back from the labs that do this because there's starting to be such a high volume of everyone, wanting data analyzed. So we've built in some time where we may just be sitting, waiting on some results coming back. But parallel, we'll be doing the alternative development on developing those site plans and getting the good capital costs. And we'll have a report in the July timeframe of 2023 to understand this impact.
So I'm sure, I mean, I'm not to be impertinent here to you or to your staff. So Bellevue, Washington is our only resort, like
It is
that-
not our only, but I'm going to say it is one of the leading labs out there working on leachate pretreatment. So what we didn't want to do was to go with someone and this be their first time trying to run these technologies on leachate. We wanted
Okay.
someone that had done it before,
Mhm.
already had the systems set up, and that we could get the benefit also of their knowledge on working with leachate because it's not like traditional wastewater. And so we've even struggled in the samples we're trying to analyze on how to get the sample clean enough to get a good PFAS measurement. So it was the lab with the right amount of experience on this in specific.
No, thank you. I was trying to understand because it's a cost,
Absolutely.
right? So
Yep.
I have to think about that. Like we
Yep.
have to think about that. So that's the reason. But yeah, I mean, and yeah, I just also wanted to understand your choice of selection,
Mhm.
why you chose. So thank you. Well, we need to know that. So thanks.
Mhm. And then our project budget. So we've broken it down by those main categories that we've been talking about. So we've got the project management, understanding our flows and loads from the pump station, the paper report for the alternatives, and then the bench testing line item. So this comes out to a total of $305,800.
Refresh my memory in terms of the leachate pump station flows and loads evaluation. Could you explain that again? That's,
Absolutely. So every time a landfill closes or opens a cell, right? So a cell is a current active area where they're putting waste. It changes the amount and type of leachate that is generated. So we've got, 10 years of data of leachate flows, and it's very different from year to year because it was different by what the landfill was doing. So if we're going to build a system, we need to understand better what their future plans are for cells and know we can't just pick the 7,000 gallons because that's what they have right now. We need to make sure we're picking a design flow rate that's big enough to accommodate really all their planned forms of operation. And that takes time and study to understand. So the other reason why we picked this consultant is because this consultant also does landfill design in addition to wastewater treatment. So they have actual landfill staff that will help us, get a better plan than let's just say like 20% flow might change.
I'm just trying to get a better understanding. How does that go into the, I guess, the bench study that we're talking about, the bench scale study?
Yep. So the treatment alternatives, when we start saying how big of a footprint do we need for this process and how much does it cost, also is sized by how much flow it has to treat, right?
Okay.
If that 7,000 gallons went to 14,000 gallons, it would be double the size and likely double the price.
Okay.
And we have to size it both for current flows and future flows. So we have to take that first step of knowing what our flow range could look like before we can get to capital costs and
Okay.
square footage.
Yeah.
Now, the company that you're referring to out in, was it Washington, I believe?
Yeah, well, yeah, CDM Smith is the
CDM Smith.
consultant.
Will they be using this information out there, or was that just internally for Loud and Water for the analysis? I'm just trying to understand.
Yeah,
Will they
the
be using that?
bench testing, the physical testing won't use it. So
Okay.
they'll test the leachate the same either way. It's
So
in
this
the
is for the-
treatment alternative when they decide how big they're going to
I
be.
see. That's what I'm trying to see, how the correlation of what they're using. the information.
Yep. So it's
Okay.
in this part of the study
Mhm.
where they need to know
Okay.
the size of
All
those.
right, thank
flows.
you.
All right. We just wanted to be clear on next steps after this. So this study is narrowly focused on the landfill leachate. We will take that information and as part of phase 3, apply it to Broad Run. There will be conversations with the county, right, in partnering on implementation, and we'll continue to monitor the regulations. So that presentation went really long, but I have a recommended motion here for the board's consideration on awarding this task order to CDM.
I have a comment. I think that this presentation was really interesting and well done. You actually got me to understand what's going on, and that's a chore.
I would have to echo Marty in terms of it was very informative, extremely informative. Thank you.
I think the word went across, so.
No, that was very interesting.
Very interesting. Thank you.
Have a motion?
I'll make the motion, the recommended motion.
This is Keith, I'll second.
Everybody in favor?
Aye.
Are we going to put this on consent, or do we want to have a presentation to the full board, or maybe
I
an
think we should have a
abbreviated presentation?
I think we should have a presentation to the full board.
I
I
agree.
was going to say,
So I would
the
put it on
informative
the
aspect.
action
of it, yeah.
agenda,
Yeah.
Actually,
if you want to go through it again.
I talk about this all the time, so that's perfectly fine.
Yeah, I'd recommend on the action agenda.
good deal.
Before we go, did you want to?
I did.
Yeah, I
Mr. Saltman.
forgot about that. Go
Yeah,
ahead.
if you don't mind, before we get into the next item, I just wanted to give the committee a brief update, really some staffing updates with the Capital Programs Department. As you may recall, Sarah Lothman and Brian Stone, they were managers within the department, and they departed the organization last spring for other opportunities. And the last couple of months, we've gone through a bit of a reorganization process, and what we did was we opened up a new vacancy for a director of capital programs. We went through that process, and we actually decided, made the selection to promote one of our very own, Savita Schlesinger here. And, so she's going to become an even more familiar face in front of the committee as her group brings the majority of the items forward. I just wanted to say a few words about Savita's experience. She's been with Loud and Water for about 3.5 years now. She helped lead us through the milestone reservoir CMAR process and then into the final design of that. I think another notable accomplishment is the Howardsville Community Wastewater Project, which has been a key partnership opportunity for us with Loudoun County. Prior to joining us, she was with CH2M Hill or Jacobs for about 15 years. So she has a ton of great experience directly within our industry and with other utilities here in the area, our partner utilities. So again, she's going to lead the team forward, and she's going to continue to partner with Pam Kennel and Tom with our Planning and Water Resources Group, and Kendra and Rick here with the capital program going on at Broad Run. And so I just ask that you join me in welcoming her to the committee, and we're looking forward to her leadership. So thank you.
I like the idea of promoting from within. I think you have a known quantity, and rather than going out of a company, you can promote somebody within who you know, and it also gives incentive to others who see that there's an upward path. So I like the idea.
Thank you for that. I truly believe that's a key part of our culture here, and a very important one. So
I think that's important because you get somebody from the outside, well, you kind of know them, but you get somebody from the inside, you know them pretty well.
absolutely.
That's good.
Thank you.
Savita,
Welcome.
you know, this new journey in with Land and Water, and I mean, definitely, I look forward to working with you further and, you know, getting great success from our side to your side. Thank you.
Okay. The next information item is Paragon Park Transmission Main Interconnect bid analysis.
Yes, so I will try and be brief because I know we have some more presentations after this one. Probably maybe a little bit more interesting than this one too. But we wanted to take the opportunity to come back and I think at the last board meeting, you approved the task order or the notice of award for this project, but we wanted to come back and talk to you a little bit about what a bid analysis looks like for us kind of at a high level, and then some more specifics on this particular bid analysis. So just stepping back a little bit, kind of a reminder on what the project is. So the purpose of this project is to allow us to be able to interconnect some transmission mains and allow us to be able to move water from Fairfax water in one zone to another one of our zones, and then also water coming from Trap Rock, back from one zone to another. So it essentially gives us the ability to have a more reliable system. We do have that capability now, but it is limited. So this will actually expand our capability and provide a lot more resiliency and reliability in this area. And it also, the demands in this area are starting to increase. And so this project is actually really critical in order to meet those demands. One thing to note is that we are trying to finish this project by the peak season in 2024. And so, but there is also a time restriction, a time of year restriction on when the connections can actually be made. So the connections have to be made between November and March. Otherwise, the demand and usage is too high to be able to take out those mains to make those connections. So at a high level, this is what we do when we're going through a bid evaluation, not necessarily in this order, but these are the steps that we generally take. So we look at the project. Once we get the bids, we look at the project and we say, how critical is this project to us? How does it fit with our overall CIP and planning? We also look at things like time sensitivity. If we delay a project, what does that mean? What are the implications to our system, to O&M, or whatever the project may be? What are the implications to deferring it? We also look at the low bid compared to the other bid results that we received. We always have a meeting with the contractor, a call with the contractor to make sure they understand the scope of the work. We also use that as an opportunity to make any clarifications and do negotiation if it's appropriate. And then we'll take a look at the bid results and compare it to the engineer's estimate. And lastly, we'll take a look if the bid is over what we originally anticipated. We'll take a look and see whether the CIP budget can absorb the difference. So for this particular project, as I mentioned, this is a critical piece of infrastructure for us. And there are some sensitivities to delaying it because of the time of year restrictions, if we had decided to delay or rebid the project, we may miss the window which we could make some of those connections for the timing. And I'll talk a little bit more about why there's some sensitivity around that. And then when we look at the bid results, and I'll show those on the next slide, but we saw that the two low bids were actually quite close to each other. They're clustered. The high bid was really kind of an anomaly compared to the other two. We did have an opportunity to sit down and talk with CPP about the scope of work. We did some small negotiations with them. We actually reduced the bid price by about $30,000. And then I will talk a little bit more about what the bid results look like compared to the engineer's estimate. So this is these are the bid results, just as a refresher for you. You can see that CPP and Sagres were pretty close to each other, with Utilities Unlimited being quite a bit higher than the other two. And then this is a breakdown of the engineer's estimate compared to the contractor's estimate. And this project has three kind of main components: the site work and the construction of the vault, the mechanical equipment, which is piping and valves, and then the electrical controls associated with the valves. So this shows the differential between what the engineer assumed versus what the contractor put in their bid price. So when we look at the different categories, when we talk about, say, the site work and the vault, there were a number of different things that the contractor assumed that were different than what the engineer assumed, including and primarily driven by their plan for excavating the vault and how they plan to shore up that excavation. Those are typically means and methods and not something that we will direct a contractor to do. We tell them what needs to be constructed, but it's up to them to decide how the construction needs to take place. The other big piece of this was uncertainty in fuel prices and equipment prices. So fuel is not a fuel price, or the price of fuel is not just how much does it cost for me to run a piece of equipment, but it also impacts things like asphalt paving, concrete, anything that requires fuel in its production. And that is all a big part of this project. The other big component was the mechanical work. And so as you can see, most of this project is ductile iron pipe and fittings. And right now there is a 52-week lead time on ordering ductile iron pipe. And the manufacturer is not able to provide a price right now. They will provide the price when the pipe is shipped. So that introduces a lot of risk for the contractor. And if you remember, we have a time of year restriction as well on when these connections can actually be made. So if we think about the schedule kind of at a high level, if the contractor is able to get his submittal into us and his piping approved in the next couple of months, it actually won't be delivered for another year, right? And then we're heading into the time of year when they can install the pipe, but they have until the end of March to be able to do that, which is also when we have winter weather that can cause delays as well. So there's kind of a narrow window for when they can actually make these connections, and that was driving some of the risk and the pricing related to their bid.
Savita, I'm sorry, Mr. Koblis has his hand up.
Okay.
Hi, Savita, can you hear me?
Yes.
So question on this. Oh, somebody took it down. I can't see it. Where'd it go? There it is. Two questions.
Yep.
One is a comment, one's a question. Number one, the question is, what was the difference in excavation that is and shoring means? I guess, I guess I don't understand why they pick one that's so much more expensive than what the engineer thought to do. So either the engineer got it wrong and couldn't be done, or something like that. And the second thing is, why didn't the engineer know there was a 52-week lead time? Even I know that there's a huge lead time on the pipe.
I'll answer the pipe question, and then I might have Matt or Sam, who are the staff that were working on this and had the direct conversations with CPP, provide a response on the excavation. That is a good question. I think you're right. Most of us kind of generally know that there is a long lead time on the pipe. I think that the biggest key, though, is that they can't get the pricing. And so the contractor has assumed what he thinks the price will be, but he can't get confirmation on that until, almost a year out. Matt, do you want to?
Well, stay still on that.
Okay,
question.
go ahead.
Is it possible or foolhardy for us to change our contracts such that we take that uncertainty out of the contract? In other words, I'm not sure how you would do this, but somehow have the price of the pipe and fittings open, that we pay it at the time of delivery, but that the contractor does not have to accept that kind of, I know I'm not explaining myself well.
That is absolutely something that we're starting to take a closer look at, but that also carries with it some risks, and we're gonna be having a lot more
It definitely
conversations about
carries
that.
risk, but it may not carry as
Quite as
risk
much, yes.
as the contractor trying to dump a lot of money on it to cover himself.
Yeah.
Just
Yes.
a thought.
Yeah.
Hey, that's a real slippery slope, like Alton was saying. But there's ways to make it so that they get, three bids or something like that, so that we can actually see the cost in a year from now. But yeah, it is a slippery slope.
No, I recognize that, but it seems like we need to do something in this crazy times that we have with prices going crazy. And the other thing I had was the same thing that you had, Mark. The site work, this is a simple vault. Why should there be, I mean, it's just a hole.
And I think the heart of your question as well, Mr. Koblis, is I believe, and I'll let others correct me if I'm wrong, but the engineer felt pretty confident in that shoring would not be required on, this is not an extremely deep excavation. And, there was some known geotech work done, albeit I believe just one boring at the vault location, but that was the engineer's feeling or professional opinion and interpretation of that information during design, and the contractor simply disagrees with that, or again, means and methods is looking to provide some increased shoring, or has built, and to that first bullet, difference in excavation has in some way built in more risk mitigation for rock excavation or whatever it may be. But we did provide and analyze that information during design.
Isn't it true that any excavation over a certain depth requires shoring? I mean, I don't know if we're in that region.
Yeah. But again, that was looked at by the designer, and that was their professional opinion on that.
I agree with Marty. There should be shoring all the time. Too dangerous.
Matt Osheki here. Just to clarify some of the specifics on the shoring, the design engineer had assumed that, so we have a 13-foot depth of excavation required for the vault. It was assumed that the first 7 feet are just soil. Came from what's that?
Turn your mic on.
Oh, can you hear me?
Yes.
Okay. So 13 feet, the geotech borers indicated that rock starts at around 7 feet. So the design engineer assumed that shoring would occur down to the first 7 feet, and the rock would support itself with the rest of the excavation. And there was actually a difference in the type of shoring that was assumed by the design engineer compared to the contractor. They were assuming timbers instead of a slide rail, steel slide rail shoring system. So that's kind of the main difference between the contractor and the design engineer. And it really comes down to the risk that the contractor is willing to accept with that shoring. So
They didn't consider something like a trench box or something of that nature? Or
It's
maybe
quite a large vault, so I
Yeah.
think that
What's that?
it's quite a large vault with 36-inch and 24-inch pipes. So.
And honestly, that's not something that we would dictate to a contractor, right? That's their means and method on how they want to secure the excavation. Okay, so this is just the last slide. I think there were some questions that had kind of come up after or during the board meeting and then afterwards. And so we just wanted to provide a little bit of insight on some things that we're looking at, kind of to your point, Mr. Sultan, about risk reduction as well. So we are going to look at what options are available to us in terms of having third-party cost estimators, provide estimates to us on some of our projects. There are kind of two options or three options really in general for us right now. We can look at bringing on a contractor or a third-party estimator, but that we'd have to go through an RFQ process, a solicitation to be able to find those folks. So that's going to take some time. And there are some pros and cons to either of those, and that's what we'll look at. The other option that we have more readily available to us now is some of our BOA firms actually have contracting arms. So they're engineers, but they also have a construction component to their business. And so we can look at utilizing one of those firms to help us do some estimates in the interim as we're trying to sort through, this particular issue. The other thing that we are looking at is how we can do some risk reduction related to the construction. And I have a couple examples of things that we have done recently or will be doing recently. So for the quarry project or from Yellowstone Reservoir, major component is underground work, right? Big shaft, deep shaft, big tunnels, long tunnels. So one of the things we're going to do is the geotechnical engineers can actually prepare a geotechnical baseline report. And so what this does is it takes the data from all the borings that were done and it creates a baseline from which all of the tunneling subs will bid off of, right? So it creates a kind of a level playing field and everybody understands what the geotechnical engineer has assumed is what the subsurface conditions will be. And then that also gives us an opportunity, if we come across some differing site conditions, a place to negotiate from, right? So we've kind of established a baseline up front. And so the bids hopefully there'll be less risk on the contractors for assumptions that they have to make on the heavy civil part. Another thing that we did, I think you guys will recall this, when with Beaver Dam Reservoir, we agreed to partially drain the reservoir to facilitate the bridge and pier work to be less risky for the contractor so that they're not working kind of in the water, right? So that was something we did recently. And then another thing we just did, we actually have a package out right now to bid for the Goose Creek Industrial Park pump station. And there were some bidder requirements in there that were causing a little bit of confusion amongst the bidders. There were some questions that kind of came back on what minimum requirements we wanted to see from the bidders. And so we made some changes to those that actually will now widen the competition or the bid pool because there are more contractors that will now meet those bid requirements. So that's something we've done recently. Some other things that we can look at is unit price escalation clauses, looking at incentives for early completion or sharing in the value engineering savings. And these would all be kind of case by case, right, project by project, but these are other things that we'll look into.
I've got some background on incentives for early completion. That's a mixed bag.
Right.
Because the minute you do something that delays him, he now has a claim that you're
Right.
hurting my incentive for early completion. So I'm not sure early completion is a great idea. I think it leads to more claims on construction contract.
Yeah, and I think it's important to note there's not one answer for every project, right? I mean,
Well, that's-
a lot of these things that we'll look at will be on a case by case basis. And there might be a particular project that something like that does make sense because we really have a schedule driver and we need to kind of get done on time, right? But I think the more important thing is just that we'll start looking into these things and kind of working with Amanda and figuring out, where the risks are to us. So we do take on more risk to lower their risk to achieve a better price. But what does that risk look like? Will it cost us more in the long run, right?
The last two items in the solutions may lower costs, but it may not narrow the gap between estimates and actual bid price.
Yes, that is true. I mean, I think the important thing to remember with a third-party estimators is that may be another helpful data point for us, but it doesn't materially affect what the bid prices will be in a low bid situation, right? Just gives us another piece of data. And I think that was all I had.
Questions or thoughts? It's a brilliance. Okay, thanks a lot. I'm a lot in favor, even though it's risky, to somehow modify our contract and take even if it's a slippery slope, at least modify our contract while prices are going crazy to see if we can accept more of the risk. And my thought is that it's possible that the risk we take may be less dollars than having the contractor take the risk. I don't know how you quantify that, but that's just my thinking. Okay, what is the next thing on the agenda? The phase 3 expansion. Road run reclamation.
All right, so we're here to give an update on the Broad Run Phase 3 expansion ahead of this year's CIP update process. So we've been working the last year over planning for the Phase 3 expansion and have some conclusions that we want to show the committee today, and most importantly, help them understand some of the changes they're going to see in the overall CIP specifically for this project. So, just to review well, let's go ahead and go to the next slide. Yes. Just to refresh ourselves, when we looked at, phase 3 expansion of Broad Run, we had some very key goals. Number one goal for this was to increase treatment capacity. So Broad Run has been in a pretty continual cycle of design and construction kind of keep up with capacity. And the goal with this expansion was to get ahead of where we needed to be and create some sufficient buffer in our wastewater treatment capacity. The third goal, which we've talked about a couple of times, is knowing that we have to meet cutting edge levels of operation due to the limited waste load allocation we have for Broad Run. So we won't go further into that. We gave an update on that at the Water Resources Committee. But the major project challenges is the complexity of what we're looking at and managing the uncertainty when you make these long-term planning decisions. So in October of 2021, we were before both the CIP committee and then brought to the board the award of the contract for the phase 3 expansion. And we're really calling this a program at this point because it's going to involve multiple steps. So at that time, it was awarded to Hazen and Sawyer that they would be the engineer through all of the phase 3 expansion. The first contract under that was our planning level contract with the key goals of what capacity do we need and what technology should be used in that. We didn't want to make the mistake of building just more of the same without taking a step back and saying, is this still the right thing? Is there something better for us to look at? So I want to start off with the increment of expansion. And we looked at this several different ways because long-term planning is tough, right? We're not looking at capacity for this year or next year. Overall, Broad Run started its planning for its initial conception in early 2000. And since then, there's really only been a 5 or 6 year period that we haven't been looking at what is the next thing that needs to be expanded in this facility. So when we lay in our phase 3 goals, we know it's going to take us 10 to 15 years to get what we're going to talk about today done. And we want to have capacity beyond 2040. So this is truly, visionary what we're talking about doing for this plant, but it's also critical that wastewater treatment be there to support the community that far into the future. And to design this complex infrastructure, it just takes significant time and effort, right? So continually spending 10 to 15 years on these increments, we want to make a good step in the right direction and increase capacity. So if we look at that original construction was 10 MGD. We then came back with what we're now calling phase 2. This is what Rick has under construction right now. And we selected just a 5 MGD increment. This was a very critical decision. At that time, when we evaluated technology, there was a new sludge processing technology called THP. It was a pretreatment step, and it had so many benefits. It reduces solids, it increases digester gas, it had a lot of benefit, but it was risky for Broad Run. It created contaminants that might affect our effluent permit. So while we did this 5 MGD capacity expansion, we piloted that technology and we proved that for a facility with our effluent permit, it is not feasible. It would risk a permit violation and wasn't a good choice. There are very few facilities in the country that would be able to see that. But now that that critical decision is made, we're comfortable making another 15 mg increment. So we're essentially proposing to double what the treatment plant is at right now and take Broad Run to 30 MGD. Key drivers for this is the continued development of Loudoun County, right? All capacity increases look at population growth and flow projections, and we took that into account. It's highly variable, right? It's really hard to say in 2045 what the population of the county is going to be. So it's one of our complexities that we manage as we move forward. We've also got the continued concentration of our wastewater. The more efficiently homes and businesses continue to use water, flows may not go up, but it gets more concentrated. That is still treatment capacity that Broad Run needs to remove those constituents. We've also got increasing wet weather due to climate change. We've seen wastewater flows from one month to another increase by 3 MGD just due to rain, right? And that is something that's out of our control to know where it's going in the future, but we do know that we have to be prepared. We also have to consider the potential of changes in county planning. If we didn't have additional extra capacity at Broad Run, we would not be able to say, yes, Loudoun County, we can handle the JLMA, we can handle the TPA. We're building, sewer and pump station for that, but Broad Run has to have the capacity to take it, and it's using up what we have in this 5 MGD expansion. That could happen in the future. So it's critical we have what we're going to talk about as buffer capacity to be able to serve the community's needs. Another interesting concept that we took a look at is Loudoun water as a whole and how much drinking water we can produce with the Trap Rock water treatment plant and our Fairfax water supply. We have the capacity to supply 70 MGD of drinking water. If we compare that to wastewater with both Broad Run and our PI capacity with DC Water, right now, we can treat about 24 MGD. The current expansion gets us to maybe 30, but we are still less than half of our water supply. And so taking Broad Run to 30 MGD gets us up to 45. So this is an important increase. The organization has invested heavily in water treatment capacity. We now need to invest in wastewater capacity so that we can treat the wastewater we supply. On average, our system is generating about 80% of the wastewater that we supply in water. So if these were to be, apples to apples, that would mean this number would need to be, maybe 55 in the long term. So we're not saying that much of an increase is necessary at this point, but what is important is that we get infrastructure to be able to treat the wastewater that generates from the water that we can provide to the county. Another important part of looking at the buffer is managing these uncertainties in wastewater is tough, but Loudoun Water isn't the only one having to do that. So Hazen went through and gathered information for us from our peer utilities. So I want to break down what we're looking at here. So what we see in blue is at the end of phase 2, if we take Broad Run and PI capacity, that's how much wastewater will be generated. The green is how much we can treat. So we'll have 21% buffer when we've finished this expansion that's in place right now. If we increase Broad Run to 30 MGD at the end of that construction, we're saying we'll have a 34% buffer. We want to see, is that buffer reasonable compared to what other counties and other wastewater treatment plants are looking at? So when we start looking at the bigger utilities in the area, everybody's got, 40 to 30%. Nome Coal, they're down here in our 25. They are also rapidly trying to expand their wastewater treatment plant.
So the Henrico County, is that the Richmond,
Yeah.
right?
Mhm.
Yeah, okay. I've been to their facility, so I was able to, yeah, so
Yeah.
the permitted design flow, yeah, so, okay.
So what you see as these percentages get low, we've got Alex Renew, they're working on their tunnel project, also looking at increasing capacity. So really being in this 30 to 40% range would get us up to the same level of buffer that these communities have. But if we look at who they are, Richmond, UOSA, Prince William Service Authority, we're looking at the highest potential of growth and right now are sitting with the lowest buffer, right? So due to our growth, this buffer is necessary and really gets us up to where we should be compared to other utilities and extra capacity to deal with uncertainties.
Do we know what the district buffer is or just?
DC Water, no, I do not. So technology selection. So what we're proposing for this 15 MGD increment, we started by taking our master plan roadmaps, checking in, screening new technologies. We brought in a technical advisory committee beyond our consultants. So we had academics, other utilities, look at our plan and say, do you think we're missing anything? And included cost benefit analysis in the selections. And this is it. This is the vision for Broad Run. And while I love these figures, sometimes I feel it doesn't do it justice for how big this is going to be. And it's really such an important step for Loudon Water's treatment capacity overall. So in white, right, in the background, you see all our current infrastructure. We're looking at essentially doubling that, which makes sense for the 15 MGD increment. On our liquids treatment side, the technology evaluation showed that we are very strong with our membrane technology and the granular activated carbon, that there wasn't a newer, better way to do this. So continuing on and building those. Now, we are going to build smarter. We've got a lot of ideas on how to do things differently in these biological reactors and improve upon what we have. The big advancement for us came in the solids technology, which is why we wanted to talk to you about the PFAS. So the move to thermal drying was really a critical decision because it positions us for PFAS removal, but was also the best cost benefit for getting additional treatment capacity on the solids. We had two options. These are our digesters. We could have built more digesters as we had, but it would have been almost the same price as getting to thermal dryers, and we wouldn't have been any closer to treating PFAS. So we're getting more bang for our buck by building these thermal dryers, but we have to realize when we start looking at costs, that's thermal drying for a full 30 MGD. It's not just a 15 MGD increment of that. We have to go back now and build the capacity to dry our initial capacity as well. So this is going to be a big facility, but comes with so many benefits that it was a sound cost benefit decision. The other thing that thermal drying does for us is diversifies our solids disposal options. So right now with just digestion, we can use land application or we have to go to a landfill as we talked about before. But with the dried process, we can use this material as fuel for a cement kiln or travel it on to pyrolysis gasification so that we're not stuck of either use it or throw it away. There are multiple beneficial uses for our output. So
One question, you may have said it before, the thermal drying, how does that differ from anaerobic digestion? I don't.
Yep, so anaerobic digestion is a large tank where we've got microbiology that breaks down the particles.
Right.
And it's also destroying pathogens with the heat and the digestion process.
Because it generates heat itself.
It does, it generates biogas, and then we use that biogas to heat the digesters. thermal drying, you don't actually have to digest it all anymore. We're reducing solids and destroying pathogens with hot air. So the entire treatment is occurring through the drying process.
So you don't need to use digesters, you just,
It's not required. We're still going to digest a portion of our flow because we want that digester gas, but not all solids we produce are good at making digester gas. So really about half of our solids will go through digestion, half will go straight to the thermal dryer. But this is now the treatment technology reducing pathogen and reducing solids. And this is what's being used out at UOSA, which is the one we went and took a look at.
do you use the digester gas to fuel the thermal?
Fuel the dryer, absolutely. And that is the nice thing about pyrolysis is the pyrolysis process also removes energy from those solids, which can then feed back to the dryer too when we get that and definitely helps supplement energy in the long term. So the important part for the CIP committee to understand is the cost associated with building 15 MGD of wastewater treatment with the infrastructure we have. And this is the change and update that you all will see to the CIP. So the current estimate, including both engineering and construction costs, is about $650 million. This is a budgetary number that we need to put in this long-term plan. We're talking about constructing this over the next 15 years. A lot is going to change in market conditions, even in our plan. We may add gasification as we go along, right? It's a budget for a 15-year program that, you know, we've estimated at a high level cost to give everybody a frame of reference. But we have to remind ourselves that the capacity is critical, right? We have to have more ability to treat wastewater, to provide the buffer for uncertainty. And it is, you know, the Loudon Water way to continue to prepare for these regulations and not wait for the regulations to come on and then be like, oh my gosh, now we have to come back and spend, you know, $650 million. So we want to talk more about these costs and how we want to manage this big budget. Broke out in the beginning that this is visionary. This will be the largest capital infrastructure project that Loudon Water has undertaken. And we absolutely understand the scale of what this ask is. So looking at the budget, right now, $540 million is in construction, and we're reserving $110 million for engineering. These are not negotiated engineering fees or CRS fees. These also aren't detailed construction estimates. They're budgetary numbers. So for our engineering budget, we've just included, you know, 10% of construction for design, 10% CRS. Our capital estimates are really what we call parametric. We're looking at similar facilities and saying it costs so much per MGD to build them and scaling together. But we've been talking a lot about what are our strategies to manage these costs going forward. And I think we have a really great plan. Don't have time to get all into the plan today, but we will be coming back soon to talk about some initial contracts. But to throw out there, you know, we're looking at breaking both design and construction into several contracts. That one gives us a couple of bites at this so that we can watch as markets change. The different contracts are required to meet timing of individual systems that we need online, but they provide us the opportunity to make adjustments as we go along and keep this project right-sized. We also wanted to acknowledge that we realize that numbers of this level require extra scrutiny and justification. So as individual contracts come forward, we will provide you all the background that we can to say these costs are justified and this is why. But at this point, this is just an overall budgetary number. So I wanted to turn it over to the finance department briefly as well in this presentation, because we've had a lot of internal talks about this to make sure that Loudon Water's financial planning is capable of this type of investment.
So the finance department is going to be me today. Brian is out today. So we just wanted to mention that when you talk about numbers of this magnitude, you know, for the finance folks, we're still kind of picking ourselves up off the floor when you look at those big numbers. But as Kendra said, it's a 15-year plan, right? And so this is all growth related. Therefore, our availability charges should and will fund this whole project. So we'll be, you know, we'll be taking a look at that fee, probably providing some updates to it as we get closer numbers. But this expansion is already in there. We've been collecting for this through the availability fee for ever since it was part of our master plan. So what will happen next is the 5-year spending for this will be built into our plan of finance, which goes through our finance committee, and we'll really see the impact of that on our borrowing. Again, keeping in mind that the availability charge will pay for this capital, but do we have enough in reserve for that, or do we borrow money? That's all what the 5-year plan of finance will answer. And then what we're doing here is really pulling forward some of these capital costs based on the planning effort that was done. We're kind of taking a little bit different approach. And so when you pull those CIP costs forward a bit, you go back and you see what that does to your financing plan. And so this is a good example of how all of these systems kind of fit together, right? So Kendra's talking about the spending and preparing for growth, and that all, you know, at the end of the day, how do you pay for it, right? I mean, that's the big question for us. And so again, it's availability charges either through, you know, current cash reserves plus debt is how this will go forward. But we just kind of wanted to add that in there because we want you to understand that this, we're aware, and it's all just part of our overall plan.
So I totally understand, like literally I do, because on 2 counts, right? One is the population growth of Loudoun County is only going to increase.
Right.
The other part is when you mentioned in your presentation is the climate, right? It's not going to get better. It's only going to get worse, right? I mean, I don't want to sound like a, but I mean, factually, right? We're on the board to talk about facts here, to base our, it's that about the sound justification, right? To support your solidifying of your sound justification. Those are the 2 biggest factors we have to consider, you know, increasing population growth and, you know, that horrible cloud on, you know, climate change that we talk about, right? So that's important. And yeah, I'm with you because there has been an increase in flow of, you know, water in, you know, in the rivers and so on and so forth. You know, that's something, as you mentioned in your presentation, that we don't have a control over. We can only control what we can control, but what we can't control is what we need to be able to prepare for. So I'm really wholeheartedly on this one. I know the number was big and, you know, 650 million and you know, big number on a big, you know, presentation, obviously, but yeah, I, you know, and I know that, I mean, I'm going to say my part, but I'm with you. I am. So thank you.
I think the whole theme of this meeting shows that Loudon Water is not sitting idle. They're thinking ahead and trying to account for everything, which I think is the appropriate way to do things. I think 650 million makes you sit back, but it's going to be there, so you can ignore it or you can start planning for it.
And really the planning for it, like I said, has been years, decades really in the making. And so it's really already being considered in our availability charge. As soon as we identify a project in our master plan, we can start collecting for it in our fees. So, you know, that is a good point, Mr. Sultan. I mean, what this is really reflecting is Loudon Water's continued effort to be proactive and prepare and be there when the service is needed. We have uncertainties about who else may need our help in the future outside of our central service area. And we talked about that at the retreat. And so to be prepared, I mean, it's kind of like the Boy Scouts, I guess, you know, that's who we are. We're always prepare,
Yeah.
both financially and with our capital programs. And so I think this presentation certainly shows that. Kendra, did you have another financial? Okay. Did you want me to?
If you want, or I can, I don't care.
Sure. So what we were really trying to highlight here is that, again, as Kendra mentioned, this will be the largest construction project that we've ever undertaken, but we have undertaken major programs in the past as well. And, getting us to 15 MGD at a cost, in today's dollars, of about 475 million. And we managed that again, both from construction to operations and financially, we handled that as well. And then we have the Potomac Water Supply Program, which also includes the quarry. And so again, managed that. And there are reasons why the second 15 MGD increment is more in today's dollars. And I think Kendra has done a great job of outlining those there. Again, we're talking about advancements, we're talking about technology. And so, again, we're preparing, we're thinking about the future and trying to cover all our bases. And we're light years ahead of others when it comes to responding to what's going on in the county and in the environment. So I think the purpose of this slide is to really not only show that, there is a difference going to the second 15 MGD increment, but it's also been managed, and we feel confident that this will be managed as well.
I understand that there's a study going on with a bunch of water utilities to look at an alternate water source for the DC area. Are we involved with that study at all? You know what I'm talking about?
Yeah, it's the Travilla Quarry, and a couple things with that. It's largely we're involved and participating kind of on the periphery. It's largely being sort of led through the ICPRB with the current 3 utilities that are part of the ICPRB's operations committee. That's Fairfax Water, WSSC, and the Washington Aqueduct. And this sort of ties into what we've kind of explained over the years. We've really put ourselves in the position of having our own supply with the quarry. And, we're very interested in what is happening there because we have a lot at stake in our through our agreement with Fairfax Water and our supply that we get through them. We want that supply in the Potomac to be, really well managed and kind of have the redundancy. But we have our own program, and so we are not going to be part of the conversations on the financial aspect and the investment in that. Now, we will play a part, again, through our wholesale agreement with Fairfax Water. But again, that will not be something that we then are participating from a separate financial arrangement. And we've put ourselves in that position over the years with our own program. But we're following it very
closely. They're going to get
closely.
an alternate water source, but that's.
Yeah, we're following it very closely. It is going to be a long process. It'll continue because they're really working through the federal government process in terms of trying to shore up investment or financial components of that.
And I'm sure down the road, if they secure that quarry, I'm sure that Loudon Water will participate through our expertise in developing our own quarry. Again, we're sort of ahead of the game there. So I would not be surprised that they don't turn to us for lessons learned when they move forward with that.
So just very quickly to wrap this up, we wanted to make sure that the committee understood, there will be a large change in the overall 10-year CIP due to this project. And so we've got a snapshot here of the sheet. Everyone can review it. Some few things we wanted to point out is how, we still got time to ramp up spending on this. We're not, gonna spend the 100 million next year. So those ramp ups have been, but key items to understand is last year's CIP included 166 million in the 10-year window. So we're making a big jump and pulling that up to 500. But as Carla just described, this is pulling forward infrastructure planning that was further out. So what was previously in the CIP was really covering another small 5 MGD increment of the same, because that's what we knew at the time. We had to complete the planning to know what the increment was going to be, what technologies we needed, and we didn't want to continually move the number around. So we intentionally waited until we had a firm plan to bring forward a change, but finance has known all along. We've been talking with them to make sure we were prepared. As I mentioned, we will be coming back relatively soon with some of the initial contracts in this work, some early site work that we know we can go ahead and get ahead on, and we'll start talking to the committee about the plans we have on taking the big program and what contracts we're going to break it into. All right, that's the end of what I had.
You talked out?
I am done. I'm thinking I went way too long. I apologize.
No, it's good.
What's next? I mean, at 10? I have a 10:30.
Oh, what time is it?
It's
I
almost
thought
10 o'clock.
The next item is the capital construction quarterly report. We can, since this has taken some time, if we can briefly do it. Yeah, well, we can do that to save some time.
Okay.
By the way, I think that this previous presentation should go to the board, full board, as an information item. I think it's important that they see that.
Okay, I'll work to condense them. I promise.
Mr. Sultan, I just want to add that that's kind of the driver for this was not only to get that out in front of the board now with those numbers, but keep in mind when we have our joint meeting in November for the 10-year plan, we didn't want that to be a surprise that those big numbers are in there. So we can certainly present it at the next board meeting. We could maybe do a condensed version at the joint meeting as a precursor to the 10-year. I'll leave that up to you, whatever you think is best.
Right. That sounds okay.
Okay, so in the interest of time here, I've jumped to the last slide in the presentation, which is the summary of the second quarter construction status of the 4 projects that Loudon Water had in construction during the quarter. And I think I'll just open it up to questions if you have any specific questions about any of the projects. I will say that the Cortland pump station, it was substantially completed late last year, and it continued at the substantially complete status through the second quarter. I'll have good news for that project in the third quarter update next month. And then, we continued to make progress on the Broad Run expansion through the second quarter. We're at 47% complete on contract time through final completion, and then about 56% spent. The Howardsville project as well, it continued to make progress there through the second quarter. It almost reached the substantially complete milestone during the second quarter. It did hit that milestone in the third quarter. And then the Trap Rock Flow Meter project and sample line just continued with construction activities through the second quarter. Do you have any questions on any of the information presented or about any of the specific projects?
My only comment is, as usual, 1.9% change orders as a percent of original contract is outstanding. When I was at Fairfax Water, we never met that, I hate to say. We weren't bad, but we never hit
Thank you.
1.9%.
Yeah, we're doing our best to keep those at a minimum.
Are there any questions? Okay, the next item is capital spending monthly report. I noticed when I read it, we're what, 70% of the estimate, or gonna be 70%?
Yeah, that's right. I'll try to be laser quick like Rick here, just in the, for time, but I will go through briefly here the mid-year reforecast that we did for the CIP spending. So last year you approved a $96.2 million capital spending plan for 2022. And every year at the middle of the year, we have a new look at all the projects. We ask all the project managers to take a look. There's 120 some projects to look at the spending through the end of the year and give our a reforecast. So it's sort of a bottom-up built reforecast, just like the initial 96 million was. And the new reforecast was that we would spend about 71 million at the end of the year of the original ask of 96. And we have sort of the variances listed here, and I'll just run through them real quick. So the first two are kind of the same, so I'll start with the first line. Projects that are either behind schedule or delayed, and therefore the impact to the budget is that we're going to defer that money and spend it in the following years. So that might be projects that either we're supposed to start this year and haven't got started yet, maybe ongoing projects that are spending slower than had been projected, or in some cases, some of those projects are reimbursement projects where the work is being done by somebody else and we need to reimburse them when they complete the work and they're behind schedule. An example of that might be, there may be the county's doing a road project and maybe a portion of that project as they're doing something, our water mains may be being moved, and we owe them some money after they move the water mains and relocate them, but their project is running behind. So we haven't gotten the bill come in yet for that. So that is all work that will continue to be done. So this $22.8 million will show up in next year's forecast for the spending for next year when we redo the CIP. The second line is almost identical to the first. It really is just breaking out projects where the county is funding those projects for us. So we kind of try to just treat those a little bit separately and just keep an accounting of them. There's a small value there of projects where we're working on them and the county's going to pay us back for them and they're running a little bit behind schedule. The third item here is projects that have been completed with excess budget and therefore money that we do not need to push forward to future years. So this may be that we estimated that a project would need to spend $2 million this year and the project actually completed this year and it's going to complete and it only needed 1 million of the $2 million. That additional million is kind of comes off the books. We didn't need it and it won't be carried forward to the future years. And then the last line item there is projects that are over budget or they're spending a little bit faster this year that was anticipated. And we cover that by just transferring money within the CIP from some other line items that were basically underspending. So this is a traditional, I think, pattern that we see many years. Standard delays on projects is probably the largest variance that we have. And I guess I'll take any questions if you have on that, but that kind of is the rationale for the ultimate reduction in spending at the end of the year.
I don't have any questions. No. No, that's. Thank you.
You're welcome.
I think that that does it. I don't think there's anything else on the agenda. Do I have a motion to adjourn?
Motion to adjourn?
Second, all in favor? That's it.
Aye, thank you. Thanks, everyone.